Okay, we've got the chapter 15, part 3.2 here. I want to discuss the solubility of zinc hydroxide at different pHs. So, for example, zinc hydroxide is a solid substance with a low KSP, which means it's insoluble. And we know that it can dissolve in water to produce zinc ions and hydroxide ions. Now, this can react with two equivalents of acid here. And if we have sufficiently high acid, it will push this equilibrium or drive this equilibrium to the right. We're looking at Le Chatelier's principle here to form zinc ion and two equivalents of water. And the question here is to figure out what is the molar solubility of this substance at pH 5. Now, there's a couple of different things we need to do. We need to figure out what is this equilibrium constant here for this chemical equation. Okay, so first we start off with the zinc hydroxide. Zinc hydroxide is in equilibrium with zinc ions and two hydroxide ions. And we call this equation the KSP. Okay, and the KSP for zinc hydroxide is equal to 4 times 10 to the minus 17. This KSP is much, much less than 1, so we say, generally speaking, in pure water, this substance virtually has no water solubility at all. Now, there's no H plus in this equation, but remember that H plus basically reacts with hydroxide to remove that from the right side of this equation, thereby pushing this reaction to the right. So what we want to do is think about the Kw reaction. Remember that water, which is in its liquid state here, is in equilibrium with H plus and hydroxide ion, and this Kw is equal to 1 times 10 to the minus 14. Now, in this top equation, we have water on the right, and on this equation that I'm scribbling down here, water is on the left. So what we need to do is flip this chemical reaction to give us H plus OH minus is in equilibrium with H2O liquid. Now, if you flip a chemical reaction, the reaction is going to be 1 over that. And so we can do that math in our head. The equilibrium constant for this equation is 1 times 10 to the 14. Now, there's one H plus here, but in our equation that we're looking at, we need 2. So we want to multiply all of these things by 2. And if we do that, we basically take the equilibrium constant and we square it. And we can also do this easily in our head by taking 14 times 2, and we get 1 times 10 to the 28th. Okay? Now what we want to do is take this chemical equation right here, and we want to add it to this chemical equation right here. And we'll do a little bit of simplification here in our head. The two hydroxides on the left and the two hydroxides on the right are going to cancel. And what you get when you add these two equations together, so So we're going to add the orange equation here, this green equation here to the equation 1. We're going to get zinc hydroxide, 2H plus, sorry I forgot the solid there, solid 2H plus, that's going to be in equilibrium with zinc ion, and 2 waters. The equilibrium constant here is going to be, again, we're adding 2 equations, so we're going to apply the product rule. The equilibrium is 4 times 10 to the minus 17 times 1 times 10 to the 28. And this will give us the equilibrium equilibrium value for this net process, and that's going to be 4 times 10 to the 11. Fortunately, we again can do this math in our head. 28 minus 17 is 11. So that's the equilibrium constant for this chemical reaction right here. Now, we can do one of 2 things. We can set up an ice table and go a lengthy way, or we can just take the shortcut. I'm kind of going to do a shortcut here. And so if we want to know what the molar solubility is for this substance here at pH 5, we basically need to know what is the concentration of H plus at pH 5, right? So remember that pH is equal to minus log of the H plus, and 5 is equal to minus log of H plus, or minus 5 is equal to log of H plus, and you can hit your anti-log button on your calculator, and you get H plus is equal to 1 times 10 to the minus 5, okay? So we have the equilibrium constant, and we know what H plus is, and we're basically trying to find out how much zinc ion is going to be, in solution. So hopefully this is all positioned on the page so you can see it here on your YouTube from the comfort of your home. The equilibrium constant, right, for this net equation is going to be zinc ion. We don't include water because that's a liquid, over H plus squared. We don't include zinc hydroxide because that's a solid, okay? So we don't include liquids or solids. And so we're going to solve for zinc ion here. The KEQ is 4 times 10 to the 11th, and that's equal to the zinc ion concentration over 1 times 10 to the minus 5. Don't forget to square that. And after you do all of this work, you're going to find that the zinc ion concentration is equal to 40. So what that means is that the molar solubility of this substance is going to be 40 moles per liter, and that's like almost astronomical, okay? So it means that this substance is completely soluble, very, very, very soluble at pH pH 5, which is acidic, okay? So if you add acid, because of Le Chatelier's principle, this drives the equilibrium to the right, okay? So that's where I want to end this video right here at the moment.